So in class, the main things we did were we went over the common factoring patterns that I think you should recognize. Whenever you are looking at factoring or have any kind of equation, you should always look for common factors and factor those out. And then you look for certain patterns, the difference of squares and the difference of cubes and the sum of cubes are all two terms. You just have to be careful that you factor cannot factor the sum of two even powers. So x squared plus y squared cannot be factored. The sum of even powers. So similarly, x to the fourth power plus y to the fourth power cannot be factored. So don't mistakenly apply factoring to those kinds of terms. You can factor the difference of squares and the difference in the sum of cubes. You should make sure that you can recognize perfect trinomial squares, and remember that perfect trinomial squares are of the form first term is a square, last term is a square, and there's always a plus, and the middle term is either a plus or a minus, and it's always 2 times the product of the square roots. And if you have a plus, then the factoring is a plus b in parentheses squared. And if you have a minus, then it's a minus b in parentheses squared. And then I'd like you to try and get good at using the trial and error method for factoring. If you like to use the AC method, that's okay. If you don't know what that is, then just keep unfoiling, as I call it, by trial and error. And then always be careful with grouping symbols when you are factoring by grouping. So we solved these equations, and we were working with throwing the ball here. And I just want to make sure that we get this done all the way. So when we did the first part of this problem, we found out that we needed this relationship, this relationship h is equal to negative 16 t squared plus v sub 0, the initial velocity, times t. And that model gives you the height that an object that's thrown straight upward, it gives you the height that that object will reach after a time of t has passed. And so you see that when t is 0, h is 0, and that means that the object is on the ground, and then at its starting place, and then it's thrown straight up with this initial speed of 40 feet per second. So we can say in this formula we can write h equals negative 16 t squared plus 40 t. And we want to know when the ball reaches the height of 24. We substituted 24 for h, and we worked that out. And we set this into its standard form for a quadratic. I like to have a positive quadratic term, so I move 16t squared and minus 40t to the other side, so it's plus 24. And then you see that you can actually simplify this by dividing by 8. Each of these is divisible by 8, so 2t squared minus 5t plus 3. And then we try to factor, because that's the easiest way to solve. So we split up 2t squared, and then for the signs, we know we have to get a positive product, so the signs have to be the same. We want a negative sum, so they have to both be negatives. And then we just have to decide where the 3 is going to go, and I think we put it here, and that gives us our two solutions. T equals 3 halves, and t equals 1. So there are 2 times when the ball reaches a height of 24. So a height is an h value. So it reaches a height of 24 when t equals 1, and then it reaches a height of 24 again when t equals 1.5. And so I think we kind of drew a rough sketch of this. See if I can go like this. All right, so if this is the height axis, so that's the y-axis represents height, and this is the time axis, so the x-axis represents time. And let's just say that the 24 is right here. 24 is the height. So let's just mark off a 1 here and maybe 2 here. So here's 1.5 and here's 2.5. So when t is 0, h is 0, so we get that point. When t is 1, h is 24, so we get that point. And when t is 1.5, h is 24, so we get that point. So we have some symmetry going here. And we know the object starts at the ground level, and it rises to the height of 24, and then it looks like it might go up. We're not sure how high it goes, but then it's going to have to come back down because it reaches a height of 24 again, and then eventually it's going to hit the ground. That's one of the things you want to know. We want to know one thing: when does it reach a height of 48 feet? So we want to know, when does the height equal 48? And so to find that, let's just move some things around here. When does it reach a height of 48? Remember, the relationship is h equals negative 16 t squared plus 40t. When does it reach a height of 48? That would mean 48 has to equal negative 16 t squared plus 40t. So again, we put this into standard form. I'm going to bring the terms to the left. Look at 16t squared minus 40t plus 48. Oops, 48 plus 48. Sorry about that. Plus 48 equals 0. And now each term is divisible by 8 again, so we get 2t squared minus 5t plus 6 equals 0, and we can factor that. Well, we can try. 2t and t. Now 6 can be factored two ways, but I think 3 and 2 or 6 and 1. Well, this is going to be interesting. Let's see. Would it be 3 here and 2 there? And they would have to both be negative. But that adds up to negative 7, which isn't what I have for the middle term, so it's not that. And I know I'm not going to put the 2 here, because if I put the 2 there, that would mean that there's a common factor of 2. But there is no common factor of 2 in the previous line, so I wouldn't put the 2 right there. So I don't think that it's going to be, I'm going to put the 2 there, I'm going to put the 2 there. I don't think that it's going to be those. So we try again. So 2t and t, now we try 6 and 1. We put the 6 here and the 1 there. That gives a 4. No, that gives a, they're both negative, so that gives an 8. That's no good. And if we put the 1 here and the 6 there, that's no good either. So this is not factorable. So we'll use the quadratic formula. Okay, so the quadratic formula says that t is equal to the opposite of b. B is negative 5, so 5, plus or minus the square root of b squared, and so 25, minus 4 times a, which is 2, times c, which is 6, divided by 2a, so 4. Now, we see what's going to happen now, because I'll show you. Now I'm looking at just the discriminant. So I'm just looking at this calculation right here. That is the discriminant, without the square root sign. If I calculate that number, it's 25 minus 4 times 2 is 8 times 6 is 48, and that's less than 0. That's a negative number. So that means that there is no real solution to this equation. No real solution. So that means that the ball never reaches a height of 48. Remember, that was the question. When does the ball reach a height of 48 feet? And we see by this that the ball never reaches a height of 48 feet. So I'm just going to erase some of these calculations that we don't need anymore. Erase all this stuff. And now we'll go on to the next question. So I'm going to get some of this stuff out of here. The next question is, get these off. Okay. The next question is, what is the greatest height reached by the ball? So I had the picture drawn. So the greatest height reached by the ball, remember we had the height of 24, say right there. We had 1 second, 2 seconds, 3 seconds, 1, 2, 3. And we knew that the ball was at a height of 24 at both 1 second and 1.5 seconds. So we have a point here and a point here. We also know that the ball, or the object, is at the ground right here. So this point where the object is on the ground is 1 second away from this point, which is where the object is reaching a height of 24. So that means if I go 1 unit to the right of that point, I'll be at another point where the object is on the ground. And also I know that if I look at this symmetry, I know that right down the center here, I have this midpoint here, and the midpoint there we can find, because we remember the formula for midpoint is to add the two coordinates. So we had 1 plus 1.5 and divide by 2. That's how you find the midpoint. So 2.5 divided by 2 is 1.25. And so that means that when the time is 1.25, the object will reach its maximum height. So we can actually figure out what that is by substituting t equals to 1.25 into the formula, the relationship between h and t. And remember, that's h equals negative 16 t squared plus, in this problem, 40 t. So make that calculation, and you can find the greatest height reached by the ball, and you know that it reaches that high point when t equals 1.25. You can also do this, well, I guess you can't do it. Yes, you can do it in a graphing calculator if you enter this into the y equals negative 16x squared plus 40x, and then look at the graph. You can find that highest point. And then for when does the ball hit the ground, we already have speculated that it's when the time is 2.5 right here. So to verify that, you would substitute the value t equals 2.5. You could substitute that into that equation, or you could take that you could solve that equation. So let's do that. We'll solve that equation for h equal to 0. So when we have h equals negative 16t squared plus 40t, we want to know when is h 0, and so we substitute 0 for h, and we solve the equation negative 16t squared plus 40t equals 0. And as we see, we can actually move these terms over here and go and write 16t squared minus 40t equals 0. We have a common factor of 8t, and that gives us 2t minus 5. And so we see that indeed we do get two solutions. First, from this factor we get t equals 0, which we already knew, and from this one we get t equals 5/2, which by the way is 2.5. So that's what we thought, and now we have proven that that is true because we actually solved the equation.